So you must be thinking, who is behind dimetrodon's fossil discoveries? Well, this was first studied by American paleontologist Edward Drinking Cope in the 1870s. According to him, dimetrodon lived from about 286 million to 270 million years ago, during the beginning to mid-Permian period. The fossils were found in the US, Canada, and Germany. In Canada, fossils were found in PEI in 1845 and was discovered by a farmer who was digging a well in the French River district south of Cape Tryon. It was also found in the Orbi Head Formation from early Permian period on the north side of PEI.
Now that we've learned a little bit more about the history of the dimetrodon and where it was found and who it was found by, let's talk about the morphology of the dimetrodon, what it really looked like. So the dimetrodon was a quadrupedal sailback synapsid. This means that it basically walked on all fours and it had a sail. Most dimetrodon species range in length from 1.7 to 4.6 meters. They're estimated to have weighed between 28 to 250 kilograms. So they were very hefty creatures. So these creatures have one large hole called temporal fenestra behind its eye socket area that can tell paleontologists what creature it is. So having one hole behind their eye socket can tell paleontologists that it's a group of vertebrates called synapsids. The temporal fenestra was very helpful because it distinguished it from most of its early sauropsids, which had no holes or two holes. So the temporal fenestra is also where some of the lower jaw muscles are attached to the skull of the dimetrodon. When looking at the skull, it shows that the eyes of the dimetrodon was positioned in the far back part of its skull. They had a big head with a very strong jaw. Now let's talk about the teeth of the dimetrodon. So the name dimetrodon means two measures teeth. The dimetrodon was given this name because it had two different types of teeth in its mouth. One was a small set, one had a larger set. So the first set of teeth, which was the larger set, was called canines, and this was for stabbing and holding prey. The shorter teeth on the dimetrodon's mouth was used for shearing and chewing prey. When looking at the body of the dimetrodon, it had four legs that sprawled out to the sides instead of under its body like dinosaurs, which made it relatively fast and smooth-moving compared to other herbivores. Now let's talk about the skin of the dimetrodon. Currently, there's no fossil evidence of the dimetrodon's skin, but scientists have theorized that it may have large scutes on its tail and belly like other synapsids. Now let's talk about one of the most defining characteristics of the dimetrodon, which is its large sail. The dimetrodon had a sail on its back that was dense with blood vessels, and it was formed by protruding neural spines from its vertebrae. There are three hypotheses as to why this sail was favored in evolution. The first hypothesis is that it was used to attract female dimetrodons. It was used in mating. The second hypothesis was for scaring prey by seeming larger than it really was. The third reason was for thermal regulation. The large sail may have helped them warm up early after sunrise and gave them an advantage over their prey that lacked the sails and would have a lower body temperature, therefore be too sluggish to escape in the early hours of the day. Let's take this brief moment to sing a song about the dimetrodon.
He's got sharp teeth, he's got sharp claws, catches prey in his jaws. He likes to stomp, he likes to roar, but dimetrodon is not a dinosaur.
Now, where were we? Let's talk about the habitat of the dimetrodon.
The dimetrodon lived in lush, swampy areas, but its environment had great seasonal fluctuations between wet and dry conditions. At the beginning of the Permian period, Carboniferous flora were still flourishing, with rich forests containing a diverse mix of plant groups. There were mossy plants that depended on spores for reproduction. By the middle of the Permian, a major transition in vegetation had begun. Swamp-loving lycopod trees from the Carboniferous period, such as the lepidodendron and the sigillaria, replaced the continental interior by seed ferns and early conifers. By the Permian close, lycopod and equisete swamps left over from the Carboniferous flora now only existed on series of islands around the equator, which now exists as South China. There is a theory that the dimetrodon used its sail for camouflage in these forests when they were hunting. At the top of its food chain, the dimetrodon was a carnivore that could take its pick for meals. It hunted a group of its smaller close relatives, the pelycosaurs. In that group were Edaphosaurus and Varannosaurus. It also preyed on amphibians such as Diadectes and Ariops, as well as other reptiles and insects.
So I think we've done a pretty good job of learning a little bit about the dimetrodons. So now let's learn how to classify them.
Like the dimetrodon, were abundant during the late Carboniferous to the Middle Triassic period. Dimetrodon was historically referred to as Plesiosaur due to its gnarled spines. However, it is now considered a basal synapsid. In 1940, Alfred Romer and Llewellyn Price classified Dimetrodon in the Sphenocontia family based on its postcranial skeleton. In 2012, Roger Benson conducted a review to discover the relationships among synapsids and potentially reclassify some synapsids. Benson confirmed that the Dimetrodon was a member of the Sphenocontia, as more specifically the subfamily Sphenocondontidae. He used the concave ventral margin of the temporal bar and the posterol dorsally sloping varanipoid premaxillae to classify the family. Dimetrodon has tall rod-like gnarl spines with vertical grooves on the anterior and posterior surface and a long nasal maxilla contact. Thus why Benson classified it as he did. Dimetrodon shares the above features with its sister species, Secadodontosaurus. After Plesiosaurs, the first mammals, came the Theraspids, which survived the Permian extinction, then Cynodonts, then us humans. We are related to the Dimetrodon, which were the first mammals.
So looks like we've successfully classified the Dimetrodon. Now, let's look at why they aren't around anymore. Let's talk about the extinction event that wiped out the Dimetrodons.
Dimetrodon went extinct 40 million years before the first dinosaurs. Dimetrodon was thought to have died during the Permian mass extinction 250 million years ago, where 70% of terrestrial animals went extinct. It is believed that Dimetrodon died earlier than the Permian extinction in another extinction event. This extinction event is called the Olson's extinction event, and it predated the Permian extinction at 273 million years ago. There is possible evidence to support the theory of the Olson event. LBG, or latitudinal biodiversity gradient, is usually shown in the fossil record as having more of a species diversity concentration at low latitudes than higher latitudes. But in the Olson's event case, it was the opposite, where less species diversity was found in these low latitudes than in high latitudes, due to the excessive heating and climate change that was occurring during the mid-Permian period. The Olson's extinction would have wiped out Dimetrodons and other species of pelycosaurs. But there are some disagreements on whether the Olson event really existed due to possible sampling biases and inappropriate time-bending strategies caused criticism in the scientific community. This is supercontinent Pangaea 260 million years ago. The red oval is the geographic location of where dimetrodon had lived during the beginning to mid-Permian period. This area includes what we know now today as North America and Western Europe, and it's the area where we find fossils of dimetrodon in locations like Texas, Oklahoma, PEI, and Germany. Dear toy makers, stop confusing kids that dimetrodon is a dinosaur, when in fact it's a reptile-like mammal.